Welcome to Ask and Learn.
In this question, we have two blocks. Block A, with a mass of 2 kilograms, is moving to the right with a velocity of 2 meters per second. Block B, with a mass of 10 kilograms, is just standing still. And both blocks are equipped with ideal spring bumpers. In the first item of this question, we have to calculate what is the maximum energy stored in the bumpers, and then what is the velocity of those blocks at that moment. We begin by noting the following. When those bumpers are compressed to the maximum, what happens is that the velocity of block A is equal to the velocity of block B, and this velocity I'm calling v prime. Then, knowing that, we can use the principle of momentum conservation. The principle of momentum conservation tells us that the net momentum is conserved before and after a given situation. So the net momentum, Pu net before, is equal to the net momentum, Pu net after. Then, by before, I mean the beginning of the situation, where only block A is moving to the right. Therefore, all the momentum is due to block A, which has a momentum given by ma times Va. Then, when that spring is compressed to the maximum, both blocks are moving to the same direction with the same velocity. Therefore, Pu net after is given by the mass of block A times V prime plus the mass of block B times V prime. Now, all we have to do to discover V prime is solve this equation for V prime, which is not a difficult task. All you have to do is factor V prime on the right-hand side and then solve for V prime straightforwardly, just like that. So V prime is given by ma times Va divided by ma plus mb. Now we plug in the values that were given by the problem and we get the following. ma is equals to 2, Va is equals to plus 2, given that we choose this reference frame where everything that points to the right is pointing to the positive direction, and then we divide it by ma, which is 2, plus mb, which is 10. This results in 4 divided by 12, and this is 1 over 3, which is approximately 0.333 meters per second. Note that I have rounded this result to 3 significant figures, since we always had 3 significant figures throughout the problem. Then, when the spring is compressed to the maximum, the velocity of both blocks is 0.333 meters per second. Now we have to evaluate what is the maximum energy stored in the bumpers. For that, we have to remember about conservation of energy. So during an elastic collision like this one, energy is conserved. This means that we can use the principle of energy conservation to evaluate what is the potential energy stored in the bumpers. The principle of energy conservation tells us that the mechanical energy Em before is equal to the mechanical energy after. And by before, I mean when only block A is moving to the right. When only block A is moving to the right, all the energy is actually kinetic energy of block A. So before, we only have the kinetic energy of block A, which is given by ma times Va squared divided by 2. And after, what we have is 2 blocks that are moving. So we have the kinetic energy of block A, ma times V prime squared divided by 2. We have the kinetic energy of block B, mb times V prime divided by 2. And we also have that potential energy stored in the bumpers, UB. Then, as we want to discover UB, we solve this equation for UB. And this is not difficult. We get the following. UB is equals to ma Va squared divided by 2 minus ma V prime squared divided by 2 minus mb V prime squared divided by 2. Then now we plug in the values that were given by the problem and the value of V prime that we had calculated before. So ma is equals to 2, Va is 2, then we divide by 2, now we have ma again, which is 2, V prime, which is 0.333 squared, divided by 2, minus mb, which is 10, times V prime, 0.333 squared, divided by 2. And by solving this, we get a potential energy of approximately 3 0.34 joules. And this is the answer to the first item of this question. And now we go to the second item. In the second item, we have to evaluate what is the velocity of block A after they separate, after the collision, and what is the velocity of block B, also after the collision. For that, we can use these equations that tells us what are the velocities of blocks A and B after the collision, provided that block B begins at rest, which is our case. Then, by applying these equations, we get the following. VA prime is given by the mass of block A, which is 2, minus the mass of block B, which is 10, divided by the mass of block A plus the mass of block B. And this multiplies the initial velocity of block A. This gives us minus 8 divided by 12 times 2, which is minus 16 divided by 12. And this is approximately minus 1.33 meters per second. So this is the velocity of block A after the collision. Now for VB prime, we have the following. VB prime is equals to 2 times the mass of block A, which is 2, divided by the mass of block A, which is 2, plus the mass of block B, times the initial velocity of block A. This results in 8 divided by 12, which is approximately 0.667 meters per second. And this is the answer to the second item of this question.